Exercise 2.9, questions number 1. The diagram on the right shows a bracelet which is represented by the curve y equal to x squared minus 3x plus 4, where points A, 1, 2 and point B, 3, 4 are located on the bracelet. The line AC is a tangent to the bracelet at point A and the line BC is a normal to the bracelet at point B. Two ends move along AC and BC and meet at point C. Find A, the equations of the tangent at point A. So first we need to find the first derivative dy dx. It will be 2x minus 3. To find the gradient of tangent at point A, substitute the x coordinate of points A into the dy dx. It will be 2 minus 3, which is negative 1. To find the equation of tangent, we're going to use this formula, and we're going to let the coordinate A here as x1, y1. Then y minus 2 equal to negative 1, x minus 1. Then y equal to negative x plus 1 plus 2. Then the equations will be y equal to negative x plus 3. Questions B. Finds the equations of the normal at point B. First, we need to find the gradient of tangent at point B before we can find the gradient of the normal. As this is the same curve, then the dy dx will be the same as questions A. To find the gradient of tangent, substitute the x coordinate of B, which is 3, into the dy dx. This is equal to 6 minus 3, which is 3. Then, when the gradient of normal multiply the gradient of tangent, which is 3, the answer is negative 1. Then the gradient of normal is negative 1 over 3. So here, let's the coordinate B as x1, y1. Then, y minus 4 equal to negative 1 over 3, x minus 3. Then, y equal to negative 1 over 3x plus 1 plus 4. Then the equations of normal will be y equal to negative 1 over 3x plus 5. Question C. Finds the coordinates of C where the two ends meet. Point C is the intersection point between these two straight lines. To find its coordinate, then we need to solve these two linear equations. So here I'm going to solve these simultaneous linear equations using the substitutions method. So first, label these two equations as equations 1 and equations 2. Then substitute equations 1 into equations 2. Then we're going to get negative 1 over 3x plus 5 equal to negative x plus 3. Next, negative 1 over 3x plus x equal to 3 minus 5. Then 2 over 3x equal to negative 2. Then 2x equal to negative 2 times 3, which is negative 6. Then x equal to negative 6 divided by 2, negative 3. To find the coordinate y, substitute x equal to negative 3 into equations 2. This is equal to 3 plus 3, which is 6. Then the coordinate of point C will be negative 3, 6. Questions number 2. The equations of a curve is y equal to 2x squared minus 5x minus 2. A. Finds the equations of a normal to the curve at point A, 1, negative 5. First, we're going to find the gradient of tangent at point A. The dy dx is equal to 4x minus 5. To find the gradient of tangent at point A, substitute the x coordinate of point A, which is 1, into the dy dx. This is equal to 4 minus 5, negative 1. Then, when the gradient of normal multiply the gradient of tangent, which is negative 1, the answer is negative 1. Then the gradient of normal is positive 1. So here, let's the coordinates of points A as x1, y1. Y minus negative 5 equal to 1, x minus 1. Then y plus 5 equal to x minus 1. Then y equal to x minus 1 minus 5. Then the equations will be y equal to x minus 6. Questions B. The normal meets the curve again at point B. Finds the coordinates of B. Let's say this is the curve for y equal to 2x squared minus 5x minus 2. And assumes that here is the point A. Then these straight lines will be the tangent at point A. Then these straight lines will be the normal at point A. With the equations y equal to x minus 6. The normal meets the curve again at point B. This means here will be the point B. Point B is the intersection point between this normal and the curve. To find its coordinates, then we're going to solve the equations of the normal with the equations of the curve. For the two equations involved, I'm going to label this as equations 1 and 2. To solve this, substitute equations 1 into equations 2. Then we're going to get 2x squared minus 5x minus 2 equal to x minus 6. This is a quadratic equation. Here we're going to write this in general form. 2x squared, negative 5x minus x will be negative 6x, negative 2 plus 6 will be plus 4 equal to 0. We can simplify these equations by dividing every term with 2. Then x squared minus 3x plus 2 equal to 0. Using factorizations, we're going to get x minus 1, x minus 2 equal to 0. Then x equal to 1 and x equal to 2. Here the x equal to 1 is going to be the x coordinate of point A. Then this x equal to 2 will be the x coordinate of point B. To find the y coordinate of point B, substitute x equal to 2. Here I'm going to substitute into equations number 2. Then 2 minus 6 is going to be negative 4. Then the coordinate of point B will be 2, negative 4. Question C. Subsequently, finds the coordinate of the midpoint of AB. So here we're going to sum the coordinate x and y for points A and B and divide it by 2. Then we're going to get 1 plus 2 divided by 2 and negative 5 plus negative 4 divided by 2. This is equal to 2 over 3 and negative 9 over 2. Question number 3. In the diagram on the right, the tangent to the curve y equal to ax cubed minus 4x plus b at P, 2, 1 intersect the x-axis at Q, 1 and 1 over 2, 0. The normal at P intersect the x-axis at R. Finds A, the value of A and B. Based on the diagram, this will be the tangent at point P. Then this will be the normal. For this tangent, we can find its gradient using these two coordinates. So 1 minus 0 over 2 minus 1 and 1 over 2. The answer is 2. We can also find the gradient of tangents by substitute the x coordinate of the point P, which is 2, into the dy dx. dy dx here is equal to 3ax squared minus 4. Then substitute x equal to 2 into the dy dx. This is equal to 12a minus 4. This 2 is the gradient of tangent. Then 12a minus 4 is equal to 2. 12a equal to 2 plus 4, 6. Then a equal to 6 divided by 12, which is 1 over 2. As we know what is the value of a, then the equations of the curve will be this. As point P is one of the points lies on the curve, then we can substitute the coordinate of P into the equations of the curve. Then 1 equal to 4 minus 8 plus b. 1 equal to negative 4 plus b. Then b equal to 1 plus 4, which is 5. Questions B. Find the equations of the normal at point P. From questions A, we already find that the gradient of tangent is equal to 2. Then when the gradient of normal multiplies gradient of tangent, which is 2, the answer is negative 1. Then the gradient of normal is negative 1 over 2. We're going to let the coordinate P here as x1, y1. Then the equations of normal will be y minus 1 equal to negative 1 over 2, x minus 2. Then y equal to negative 1 over 2x plus 1 plus 1. Then the equation is y equal to negative 1 over 2x plus 2. Question C. Finds the coordinates of R. Based on the diagram, the point R is the x-intercept. Therefore, the y is equal to 0. To find the x-coordinates of point R, substitute the y equal to 0 into the equations of normal. Then, 1 over 2x equal to 2. X equal to 2 times 2, which is 4. Then, the coordinate R will be 4, 0. Questions D. Finds the area of triangle PQR. So here we're going to use the shoelace formula. As for the 1 and 1 over 2, I can write this as 3 over 2. So here we're going to arrange the coordinate anticlockwise starting with point P. So 2, 1, 3 over 2, 0, 4, 0, then end with the first coordinate. Next, we're going to sum the products in these directions. Then minus the sum of products in these directions. This will be 1 over 2, 4 minus 3 over 2. This will be 1 over 2 times 5 over 2. Then the answer will be 5 over 4. Or 1 and 1 over 4. Questions number 4. The diagram on the right shows a part of the curve y equal to ax plus b over x. The line 3y minus x equal to 14 is a normal to the curve at P, 1, 5, and this normal intersect the curve again at Q. Finds A, the values of A and B. First, we're going to change the equations of normal given in the form of y equal to mx plus c. Then 3y equal to x plus 14. Then y equal to 1 over 3x plus 14 over 3. Then the gradient of normal will be 1 over 3. So when the gradient of tangent multiply with the gradient of normal, which is 1 over 3, the answer is negative 1. Then the gradient of tangent is negative 3. So here we can also find the gradient of tangents through the dy dx. Here we can write the equation of the curve as y equal to ax plus bx to the power of negative 1. Then dy dx equal to a minus bx to the power of negative 2. This is the same as a minus b over x squared. To find the gradient of tangent at point P, substitute the x-coordinate of point P, 1, into the dy dx. Then dy dx equal to a minus b. As negative 3 and a minus b is referred to the gradient of tangent, then a minus b equal to negative 3. To solve this, we will need another equation. As point P is one of the points on the curve, then we can substitute the coordinate of P into the equations of the curve. Then we're going to get a plus b equal to 5. Next, we're going to solve these simultaneous linear equations using the eliminations method. To eliminate the a, I'm going to use equations 2 minus equations 1. So b minus negative b, we're going to get 2b equal to 5 minus negative 3, which is going to be 8. Then b equal to 8 divided by 2, which is 4. To find the value of a, I'm going to substitute b equal to 4 into the equations 2. Then a equal to 5 minus 4, then a equal to 1. Questions B. Finds the equations of tangent at point B. From questions A, we already find that the gradient of tangent is equal to negative 3. So here, let's the coordinates of P as x1, y1. Then the equations will be y minus 5 equal to negative 3, x minus 1. Then y equal to negative 3x plus 3 plus 5. Then the equations of tangent y equal to negative 3x plus 8. Question C. Finds the coordinates of Q. So the point Q is the intersection point between the normal and the curve. To find its coordinates, then we need to solve for the equations of normal and the equations of the curve. From questions A, we already find what is the value of A and B. Then equations of the curve will be y equal to x plus 4 over x. In questions A, we already convert the equations of normal in the form of y equal to mx plus c. Then the equations of normal will be y equal to 1 over 3x plus 14 over 3. To solve this, substitute equations 1 into equations 2. X plus 4 over x equal to 1 over 3x plus 14 over 3. First, to get rid of the denominator with the x, then we're going to multiply each terms with x. X squared plus the x here will be cancelled, just left with 4 equal to 1 over 3 x squared plus 14 over 3 x. Next, to get rid of the denominator of 3, then multiply each terms with 3. Then we're going to get 3x squared plus 12 equal to, so the 3 here will be cancelled, left with x squared plus, cancel the 3, 14x. So this is a quadratic equation. To solve this, we're going to write this in general form. So 3x squared minus x squared will be 2x squared minus 14x plus 12 equal to 0. We can simplify the equations by dividing every terms with 2. Then x squared minus 7x plus 6 equal to 0. Using factorizations, x minus 1, x minus 6 equal to 0. Then x equal to 1 and x equal to 6. So x equal to 1 is the x coordinates of the point P. Then x equal to 6 will be the x coordinates of the point Q. To find the coordinate y of point Q, I'm going to substitute x equal to 6 into equations 1. This is equal to 20 over 3 or 6 and 2 over 3. Then the coordinate Q will be 6, 6 and 2 over 3. Questions D. Finds the coordinates of the midpoint PQ. So here we want to sum the x coordinate and the y coordinate of the point P and Q and divide it by 2. It will be 1 plus 6 divided by 2 and 5 plus 6 and 2 over 3 divided by 2. This is equal to 7 over 2 and 35 over 6. Or 3 and 1 over 2, 5 and 5 over 6. Questions 5a. The tangent to the curve y equal to square root 2x plus 1 at point A, 4, 3, intersect the x-axis at point B. Finds the distance of AB. So first we're going to find the equations of tangent. For the equations, I can write this as y equal to brackets 2x plus 1 to the power of 1 over 2. Then dy dx is equal to 1 over 2, 2x plus 1 to the power of negative 1 over 2. Then differentiate the terms in the bracket, which is 2. Then we can cancel for the 2 here. Then this is equal to 1 over 2x plus 1 to the power of 1 over 2. Or I can write this as square root 2x plus 1. To find the gradient of tangent at point A, substitute the x coordinate of point A, which is 4, into the dy dx. The answer will be 1 over 3. To find the equations of tangent, let the coordinates of points A as x1, y1. Then the equations will be y minus 3 equal to 1 over 3 x minus 4. Then y equal to 1 over 3x minus 4 over 3 plus 3. Then y equal to 1 over 3x plus 5 over 3. So this tangent intersect the x-axis at point B. So here will be point B. B is x-intercept, therefore the coordinate y is equal to 0. To find its x-coordinates, then substitute y equal to 0 into the equations of tangent. Then 1 over 3x equal to negative 5 over 3. Then multiply 3 for both sides. So the 3 will be cancelled. Then x is equal to negative 5. Then the coordinate b will be negative 5, 0. To find the distance AB, we're going to use this formula. So here I'm going to let the points A as x2, y2, then point B as x1, y1. Then substitute it into the formula. This is equal to square root 9 square plus 3 square. Then the answer will be 3 square root 10. Questions 5b. The tangent to the curve y equal to hx cubed plus kx plus 2 at 1 and 1 over 2 is parallel to the normal to the curve y equal to x squared plus 6x plus 4 at negative 2, negative 4. Finds the value of constant h and k. So first we're going to find the gradient of tangent. dy dx is equal to 3h x squared plus k. To find the gradient tangent, substitute the x equal to 1 into the dy dx. This is equal to 3h plus k. Next, for this curve, we're going to find the gradient of normal. Here, the dy dx is 2x plus 6. To find the gradient of tangent, substitute x equal to negative 2 into the dy dx. This is equal to negative 4 plus 6, which is 2. So when the gradient of normal multiply with the gradient of tangent, which is 2, the answer is negative 1. Then the gradient of normal is negative 1 over 2. As the tangent of this curve is parallel to the normal of the other curve, then the gradient of these tangents will equal to the gradient of the normal. Then 3h plus k equal to negative 1 over 2. To find another equations involving h and k, we're going to substitute these coordinates into these equations. Then the equations will be h plus k plus 2 equal to 1 over 2. Then h plus k equal to 1 over 2 minus 2, which is negative 3 over 2. So here we're going to solve these simultaneous linear equations using elimination method. To eliminate the k, I'm going to use equation 1 minus equation 2. So 3h minus h, we will get 2h. And negative 1 over 2 minus negative 3 over 2, the answer is 1. Then h is equal to 1 over 2. To find the value of k, I'm going to substitute h equal to 1 over 2 into the equations number 2. Then k equal to negative 3 over 2 minus 1 over 2. Then k equal to negative 2.